And we're live.
And we're live. Good morning, good afternoon, good evening to all of you who are joining us today.
And thank you so much for tuning in.
Welcome. We'd like to welcome you officially to the GCP online meetup. This is episode 9.
Yes, we are on episode 9 officially.
So thanks for joining us today.
And thank you so much.
Yes. And so brief round of introductions. My name is Anthony Bouchon, and I am a customer engineer based out of San Francisco, working with Google Cloud Platform.
I am also a customer engineer based here in San Francisco on the Google Cloud Platform, specifically focusing on games. So we're the killer games team for any game needs that you guys have. Little plug there.
And her name is Vivian Boykin. So we are joined today by Jacob Simpson from the Kubernetes team based out of Google Seattle. So Jacob, if you want to introduce yourself.
Yeah, I'm a developer on the security team on Kubernetes project based in Seattle, and I am one of the team that builds not just contributions to the open source Kubernetes, but also to Google GKE, which is the hosted product that Google offers.
Awesome. Yeah, we're very lucky to have you here and to have some of your time. So we're excited to see what you have prepared for us today. I think a brief round of administration is to, if you are joining from a lower resolution, be sure to change your YouTube setting to 720p, as a large portion of today will be Jacob's demo, and we want to ensure that you're able to see what's actually going on. Anything else?
So with that, take it away, Jacob.
Okay. So just give me a moment to get my slides going. Okay, so this presentation is specifically covering RBAC on GKE. So RBAC has reached a level of maturity very recently, and it's come out in Kubernetes 1.6. It's very usable and integrated with the product, and we are releasing it as part of, or it's available as part of GKE just recently when we rolled out the Kubernetes 1.6 changes. So my name is, as you know, Jacob Simpson. I work on Kubernetes in Seattle. So this is my contact information, and also there is a GitHub repository with all of the details about the demo that we're going to be going through as we get further along. I'll pop this up again at the end of the slide, so if you missed it, it'll be available again. So I'm going to assume that there's not much background in RBAC, so if people are really familiar with this, or at least some of the principles, just bear with me for a bit. RBAC specifically covers authorization. It allows you to set the permissions that govern what you can do within the Kubernetes cluster. So you may use it for, and there's 2 specific reasons why it's interesting for people who deal with Kubernetes to know about RBAC. Either you have security concerns about your cluster and you want to lock it down, or you want to separate the level of permissions that are available to different teams and different users, or possibly between different kinds of deployments. You may have a staging area that's wide open and a test area that's of somewhat more limited distribution, so that your QA people can be really reassured that not everybody is deploying there and disrupting their testing when they're least expecting it. And you may have production quite locked down to a limited number of people who are doing support. Also, you may find that some applications that run on GKE or within Kubernetes use the API itself to affect the state of the cluster. And there's things like Helm, which do deployments packages within the cluster, or Jenkins, when it has the Kubernetes plugin and it integrates. These things actually talk to the Kubernetes API and use the Kubernetes API to affect the state of the cluster. And so RBAC can affect the functionality of these applications if it's not correctly configured. So authorization. RBAC is all about authorization. That means that it's deciding what you have the permissions to do within your cluster. It's not about authentication, which is proving who you say you are, which passwords or tokens or all of these things are about proving that you have a certain identity. RBAC is entirely about authorization. And for the purposes of this talk and the demonstration that I'm going to have, I'm going to skip right by authentication, which there's a lot of variety in authentication. So if I brush over it, just it's because I'm just focusing on authorization and the permissions in this one. There's only a few basic concepts that are covered in RBAC, and if you understand how these things relate, then it's relatively easy to reason about RBAC and deal with it. These things did not match my intuitive understanding of these words when I first encountered RBAC, and so I am going to spend a little bit of time explaining exactly how these words are used within RBAC itself. So there's roles and role bindings and subjects, which is just the general word for users or service accounts.
Hey, and Jacob, quick question before we dive into RBAC. I guess Vivian and I are kind of wondering if you could talk to a little bit about, I know that RBAC is something that is in beta with Kubernetes 1.6. And so we do want to kind of hear about how people were doing things before. I think that, maybe putting this in context compared to, let's say, attribute-based access control would be some helpful context to show why we're excited and why we think RBAC is great in 1.6 and why,
absolutely. So Kubernetes actually allows a number of different authorization mechanisms to be used. RBAC has been in alpha for a while. But as you say, with 1.6, it comes to beta, and it's reached a level of maturity that makes it really usable. Previously, the most configurable option that you had before was ABAC. ABAC, the most prominent thing about ABAC that made it a little more challenging to use was that it's file-based, so you log on to the master of your cluster with an SSH account, and you use your text editor to edit a text file, and you make some changes, and then you restart your API server. And when that takes effect, then everybody who's affected by the permissions that you've just configured now gets their changes. So it's difficult to give away the ability to manage permissions, for example, because you have to give away SSH access to your cluster, and it's very privileged. So RBAC itself, I'm sorry, do you have a question?
No, that's great. Okay. Sorry, I didn't mean to cut you off.
No, that's all right. RBAC, is actually, access to it is available through Acute Control. And so anybody with command line access that has the right permissions can make RBAC changes. And so you don't have to give away SSH access to your cluster master.
Got it. So kind of the old way of doing things, maybe using ABAC, would be pretty much to just edit a static file that controls all of these users and permissions.
Yeah.
Okay.
Yeah.
Awesome.
Okay, so the essential part of permissions is simply to create a connection between your user and the things that you wish that you could do, and the objects that you wish that you could operate on. If you have a role, it's nothing more than a grouping of objects and operations. So that's the part that wasn't intuitively obvious to me when I first encountered RBAC, but that's all it is. It's just a grouping of resources and the operations that you're permitted to do if you have that role. And a role binding is the connection between a user and a role. And because the role binding is separate from a role, you can have multiple bindings to many different users or to groups or to service accounts. So when you create a role or a role binding, they actually exist within a namespace, within a Kubernetes namespace. And they're only relevant to the objects within that namespace. So when you create a role and it talks about pods, it's only relevant to the pods that are in the namespace where the role exists. And the binding is only effective if it also exists in that same namespace. Now, there are interesting scenarios where we would like to be able to grant the same kinds of permissions to people in different namespaces. And an example of that is if you have multiple teams, each team gets their own namespace, and you want somebody on that team to be an administrator of their namespace. In that case, you create a cluster role, which is a role that crosses namespaces, and then the binding exists within the namespace to connect it to a user. And that means that that user, as connected by the pink lines, is only going to have permissions within their own namespace. But the kinds of permissions that they have are going to be the same as every other person who has that role in their own namespace. So and this is going to cover a little bit the fundamentals of how a Kubernetes cluster works. This may be quite obvious to people, but I'm just going to take a moment to point it out because it really affects how you think about where the permissions actually matter. Because there's many cases where people won't care very much about permissions, and I'm going to cover those scenarios in just a moment. So when you have a Kubernetes cluster, it has a master, and the master has a control plane with a few components. The one that we're primarily concerned about here is the API server. And it's the API server where these permissions are enforced. So ACute Control is a command line client that connects to the API server. ACute Control has no special backdoor access or anything. It is simply a client of the API server. And so ACute Control is affected by RBAC. And that allows you, that's what allows you to give away permissions to a specific namespace, to a specific set of users. They have their ACute Control, and the API server will enforce the permissions that they're allowed to have. The other place, Kubelet talks to the API server and can be affected by RBAC permissions. There are default roles and role bindings that cover the kubelet. So this really shouldn't be a concern in most cases. Haven't seen anything happen where this is a problem. But nonetheless, the kubelet is not special. There's no backdoor access. It goes through the API server. And so it's subject to RBAC as well. Now, here's the situation where you may have figured out that you don't actually care very much about RBAC. If you have an open cluster, you're not very particularly worried about ACute Control. And if you're running a standard application that doesn't interface with the Kubernetes API server, like an Nginx deploy or a simple Tomcat application, these things don't have any connection to the API server. They don't need permissions to the API server. And you can use RBAC to give them no permissions, which if there's a security problem in that container, it doesn't have any connection or it doesn't have any permissions to connect on and act on your Kubernetes cluster. There are situations where you might be running a pod or a container within your cluster that you do want permissions, and a custom controller is one of those things. Another one is you may run an application that interacts with that affects the state of your cluster. Jenkins with the Kubernetes plugin or Helm, these are examples of things that actually affect the state of the Kubernetes cluster. So that's all with the theory. I'm going to do a demonstration and a walkthrough right now. This is the GitHub repository where all the details about what I'm going to do are available. All right, I'm going to switch views now. Give me just a moment.
Ooh, got a little Hangouts inception going on. And I think that was, Jacob, that is an especially helpful overview. I think that, for the online meetup community that we have, I think that we find a wide variety as far as the familiarity with Kubernetes. We'll have people who are already developing and hence their interest in attending. And then we have people who are just trying to familiarize themselves with microservices, architecture, and containers. So yeah, the slides were great.
Okay, all right. Okay, so I've actually done some preparation in advance, and so there are some things that I'm going to be skipping over here. I have a cluster that's already set up, and I've already created all of the GCP service accounts that I need to do this demonstration. The details of how I did this are in the GitHub repository, so if you feel the need to really dive into the details and see where this came from, that information is available. But especially with regards to the GCP service accounts, there's many steps involved in getting a user set up, and it didn't really add to the RBAC demonstration to show those. So,
and just as a bit of a to prime the audience as to what we're going to be walking through, I think that this cluster that you've already created, or the GCP resource, this is something where you've already created namespaces, or is this are we going to walk through that as well?
I'm actually going to do that right now.
Perfect. Awesome.
Yeah. So it's just the cluster, and it has the users. And oh yes, one other thing that I should mention here. This is a bit of the part that got complicated. I've set up an alias for ACute Control, and the only thing special about the alias, so when you see me typing certain commands, because this is the A-ACute Control, that means that's the administrator. So the only thing special about that ACute Control command is that it is authenticating to the Kubernetes cluster as an administrator. Now, I have some other users I've also set up, and they are authenticating as cluster user 1 in this case. And I also have cluster user 2. And this is going to give me the ability to run commands as different users, and I'll be able to show you, the administrator will be able to make the updates that are necessary for the demonstration, and I can show you when things are failing with the other users.
Ah, love it.
Okay. So first of all, the administrator is going to create some new namespaces. And the general idea is simply, say that you have 2 teams. This is one scenario that we deal with our larger customers. If you have 2 teams, you may have 2 namespaces, and you give one team access to one namespace and another team access to another namespace. Another scenario that you may encounter is staging, testing, prod. And the distribution of permissions in that case is going to be slightly different. You may not have 3 distinct groups that have access. You may instead find that everybody has access to staging, a fewer number of people have access to testing, and your support personnel are mostly about production. Or you may be running in an even smaller situation and everybody has access to everything, but then you're probably not too worried about RBAC. So in this case, we're going to be addressing the scenario where we're going to be trying to give permissions for user 1 to access the objects that are in namespace 1, and user 2 to access the objects in namespace 2. And mostly, they won't have any cross-pollination, although we may do a little bit of sharing, because sometimes scenarios happen where a user in namespace 1 is an administrator, but has view access to namespace 2 so that they can see what the other team is working on. So now that our namespaces are created, we get to see what kind of things are available. So user 1 get pods in namespace 1, and we get the forbidden error because there's no permissions available. So first things first, as we saw previously, what we're going to do is create a role. So this is going to be the pod reader role. It's going to allow you to do a get, a list, a watch on the resource of pods, and it's going to be specifically limited to namespace 1. Now, just for demonstration purposes, I've done everything on the command line so that it's all easily visible. When you're working in a more repeatable manner, you're probably going to be using YAML files and manifests for creating your roles and your role bindings. And certainly that's how I would do it in other situations. You would be able to check those into your source code repository and manage them. And that's by far better, but it makes for a better demonstration when I can clearly show you what's going on. So in this case, here we are, we're going to create a new role for pod reader. So here we are, no problem. And the next step is I have to create the connection between the new role and the user account. So this is the role binding. It has a reference to the role and to the user account and the namespace that we're going to put it into. And once that's done, there's no resources found. Perfect.
There we go.
So also of note,
And what are you doing currently?
so right now what I'm going to do is I'm going to try and run a pod in my namespace as user one. And so this is going to fail because being able to create a pod was not on the list of verbs that I applied in my role up above. So if you look, I'm not sure if my highlight is visible there. Hopefully it is.
Yep.
Okay, so the only three verbs that are available on the pod resource are get, list, and watch. Create isn't there. And so when I try and run Nginx, what it's telling me is that I don't have create permissions. Actually, very specifically, it's telling me I don't have a create permission for a deployment because when you do a run, it tries to create a deployment and then a pod. But it would fail for a pod creation as well.
And what I find, Eric, to be, I guess, since we are all about trying to make RBAC cool in Kubernetes, I mean, if you go back up here when you're creating this role pod reader, you're actually getting a lot of granular, declarative kind of what can this user do as far as if we see the get list. This is something that, you know, can you talk to previously the way that people were kind of, was there a way that people were restricting these or to get this granular as far as who could do what with resources in a cluster?
Honestly, I'm not quite as familiar with the limitations of ABAC. It did give you some level of granularity. I don't think it gave you this level of granularity, and it was more difficult to use. I didn't see any indications of it being used. In GKE, we didn't actually allow any configuration of the legacy authorization mechanism.
Yeah, no, I mean, I can think of a couple customers, and I'm sure Vivian can as well, as far as, you know, as you begin to get to a certain size and have multiple teams working on different things within the same cluster. I mean, this is amazing as far as being able to really be able to make Kubernetes more of an enterprise production ready platform as far as, you know, being able to control access for a larger team. So this is awesome.
Yeah, yeah. There's a few basic concepts involved, but it's very flexible and relatively easy to use and to delegate responsibility, which I rather enjoy. Instead of necessarily needing one person to be able to do everything, you can actually give away the permissions to manage permissions. Yeah, it's an odd thing to talk about, but RBAC is governed by RBAC. So the permission to grant permissions is a permission.
Right, and you know, I think that, you know, there's so many ways in which Kubernetes is kind of changing the way we do things, and you know, something as simple as, or not simple, but something as a little, I guess, is less sexy as far as features go. You know, I don't think that RBAC gets as much love as let's say other features, and so I think, you know, it is important to point this out to users as well.
Yeah, yeah, and this one's it's really come to a level of usability that's very interesting.
Awesome.
So just so that we have something to look at, I'm actually going to use the administrator user, and I'm going to create that pod that I tried to create before. And so now that I've got an Nginx instance running, here we are. User 1 should be able to get pods in that namespace, and now they have something to look at. Okay, so next we have user 2, and he would really like to have some access as well. So get pods for user 2 on namespace 2 fails, cannot list pods. So first thought is, well, user 2 needs exactly the same kinds of access that user 1 needs. It just has to be in this other namespace. And so using the administrator user, I create a role binding that creates an association between the role that I created previously and user 2 and puts the role binding into namespace 2. Now, I mean, if I was clear previously, that really shouldn't have worked. And sadly, the truth of the matter is it didn't work. It didn't fail, which is unfortunate. And this is actually a thing to be aware of with RBAC, is that some of the commands won't fail, but they won't succeed either. They don't create a usable configuration. And so this is one of them. Because the role, pod reader role here was created up in the namespace 1, it can't be used in namespace 2. So if we just take a look, get roles. So the administrator user takes a look and says, look, here is the pod reader role, and it exists in namespace 1. So even though we were able to successfully create the role binding in namespace 2, it's not effective. It can't function, which is why we still have this error message when we try to get pods. In fact, and I'm doing this demonstration for people who do end up playing with RBAC. This is a thing to be cautious of. Just because the command executes does not mean that you got what you wanted. For example, here is a role binding that creates an association between the fallacious role and user account 2. There is no such role, but it's still going to create the role binding for me.
So are there any commands or any good tricks that you can use to mitigate that risk of error?
Not at this time. The best that I can come up with is to do inspections and trials. So it is possible to get the details of the role binding. So in this case, what I can do is ACute Control, get role binding. If I get the details about this role binding, oh, because I'm in the wrong namespace. Get the details about this role binding. It's going to show me the role that it's referring to, and through inspection, I'm going to be able to take a look at that and say that it's non-functional. But other than that, at this time, I don't actually have a good tool to cover this. This is an issue that we should find a way to address.
But inspection definitely helps then. That's exciting to know.
Yeah, inspection helps. Okay, so actually creating another role in namespace 2 for user 2 wouldn't prove anything because everybody's already seen that demonstration. So just so that there's I am, however, going to, because sometimes it's interesting for another user to have permissions across multiple namespaces if you have a user that needs to have viewing permissions or something. And so in this case, we're actually going to give some permissions to user 2 in namespace 1, which will demonstrate that we can reuse that role. We just have to make sure that we use it in the right namespace. So we saw that user 2 tried to get pods in namespace 1. And here we are, we're going to create another role. Going to find the pod reader role, associate it with user 2, and put it into namespace 1. So the role binding itself will go into namespace 1. Once that's done, I now have view permissions into namespace 1. Okay, so that's the basics of roles and role bindings. The next interesting one is if you have multiple teams working in different namespaces, it's going to be a fairly common scenario that you want them to be able to do the same things, but only in their own namespaces. And so that's when you get to cluster roles. And so cluster roles are also worth knowing about, because if you do a listing of roles, which I will do here, so these are all the roles that are available on your cluster. These are not all the cluster roles that are available on your cluster. So if you go looking for a role and you can't find it, you may be looking for the wrong kind of role. It's something to keep in mind, because a role binding can apply to, oh yes, because a cluster role is not namespaced, so I don't need to say all namespaces. So these are the standard cluster roles that are available. Some of these are used by the system, and they're prefixed with system : as you probably would have guessed. And some of these are actually reusable. So when I talk about being able to distribute the administration to different users within a cluster, the admin role is pre-created in a Kubernetes cluster specifically to help with this. Actually, admin, edit, and view are all intended for this purpose, and they're cluster roles, and you can associate them with a user in a given namespace using a role binding, and they will be an administrator of only that namespace. So for this demonstration, I'm going to switch to using deployments instead of pods so that I have a new resource to grant permissions on. So here, user 1 is trying to list the deployments in namespace 1. And ideally, our approach is going to be, we're going to create a cluster role that manages the permissions we want user 1 and 2 to have. And we're going to create 2 separate bindings so that user 1 has that role in namespace 1 and user 2 has that role in namespace 2. And so this is probably fairly obvious, but I'm just going to throw it out there. This is the command that will create the role that we're looking for, but it's only a role, not a cluster role. Now, I haven't specified the namespace, but that doesn't mean that it's not going to go into a namespace. What it means is it's going to go into the default namespace, which is an ordinary namespace like all namespaces. It simply happens to be the place that things go when they're not namespaced. So creating a role this way will not allow you to share it between different namespaces. So when I do a listing, there it is, and it's in the default namespace. Okay, so what we are looking for is a cluster role. which is this one. It also does not specify a namespace, but in this case, that's because it doesn't belong in any namespace. So once we've created the cluster role that we're looking for, we can create a role binding. So this role binding is an association between the deployment cluster role and user account 1 in namespace 1. Okay, so the role binding was created. Now that user will have the permissions associated with them in namespace 1. And there is the deployment that I created previously. Now, if we check namespace 2, still denied permissions. So the role binding was only relevant to the namespace that it was created in, and it was created in namespace 1. Now we're going to do something very similar for namespace 2. So there is namespace 2. It's trying to get access, or user 2 is trying to get access to namespace 2. And I'm going to reuse the cluster role that I already demonstrated. Yes, so the cluster role is the deployment reader. The user account is user account 2. And the namespace is namespace 2. So once I've done this, user 2 has access to the deployments in namespace 2, but not in namespace 1.
Right. And just to bring it back to sort of this real-world situation that we were talking about earlier, is that now, you know, for let's say namespace 1 or namespace 2, we can kind of replace that with, let's say, test and production or something like that, where we do have these roles that have a specific set of actions that a user can take, but now this role binding allows us to take that set of roles and really get a little bit more granular as far as, depending on what namespace, they may or may not have that list of actions that they can take. Is that right?
That is correct, yeah.
Awesome. Yeah, I mean, I'm just thinking about it in the context of, I think, within Container Engine. So for those of you who are out there and watching, Container Engine is Google Cloud Platform's managed Kubernetes offering. It provides a fully managed master, among many other things. But one of the features that I remember that was before kind of 1.6, where RBAC was in beta, is actually using Cloud IAM to designate roles in the cluster for your Kubernetes cluster within Container Engine. Now, if I remember correctly, and Jacob, keep me honest, but I think that those roles did not have this capability as far as being able to segment by namespace, which I think is it's a game changer. Almost got my. But yeah, I think that so that leads me into a question as far as, is this something that would ultimately replace, let's say, delegating these roles through Cloud IAM, or is there any plan of like how maybe you can use these in conjunction, or what's sort of the story there?
Yeah, that's a good question. So as you're absolutely correct. Previously, we could delegate some level of permissions using IAM in Google Cloud Platform. But as you say, it didn't give you the ability to go to this level of granularity. In fact, if I remember correctly, it's really only can you create a cluster or not. It's really that level of granularity with just the cluster itself. But
Right.
RBAC gives you a very fine degree of granularity that just IAM is not providing. Now, as for going forward, both of these things are enabled and in use. IAM doesn't provide you with this granularity, and when you get inside your cluster, then you will be using RBAC for finely detailed granularity of permissions within your cluster. The users are shared. So for all of these examples that I'm giving here, the administrator user, the user 1, user 2, these are actually Google Cloud Platform Service accounts.
Mm-hmm.
And so your Google Cloud Platform Service accounts are available here, and you get to assign them these permissions.
Got it. So it's almost like you can take what Cloud IAM was able to do and really extend it to a much deeper level with RBAC.
Yeah, exactly. You get very detailed access into the cluster, and you get it in the same way that you would get it if you were using Kubernetes anywhere else. As long as they're using RBAC, which is the most powerful and preferred method right now that it's gone to beta, you will find that this is a common experience if you happen to run both on-prem and GKE, or if you have a GCP cluster and or a GCE cluster, which is just Kubernetes on Google VMs, as well as GKE for some reason. Or even if you came from AWS, you can see RBAC, and this level of control is available on all of those platforms as long as you're using Kubernetes 1.6+.
Sweet.
That's incredible. So you can definitely use this for your hybrid cloud approach then.
Yeah.
Awesome. And that's, again, that's what a lot of enterprises really care about, and as far as evaluating and moving into Kubernetes. And so I think it's great for all of us as far as advancing Kubernetes and in the kind of landscape of
open source. Yeah.
Exactly. I think so. I may push RBAC to where it's at right now. Or, well, I do have a quick question, Jacob. So as far as federation, so let's say being able to control resources across clusters, is there any support for RBAC within that, or not quite yet?
To tell you the truth, I'm not sure. So the way that I understand federation is that it's communication between existing clusters. And probably the heart of your question is whether or not these roles and role bindings would be shared across federated clusters. Because RBAC will certainly work within each of those separate clusters. I'm relatively sure of that. But whether or not it will have the same sorts of roles and things be shared across them, I don't know about that.
Okay. I think that, yeah, I think it'd be good for everyone who's attending to kind of, if you haven't heard of Federation, definitely look at it as well. I think that's probably the most compelling story as far as Kubernetes moving forward. But that's for a whole nother meetup, actually. So write that down.
To be continued.
Yes, exactly.
Okay, so that's really all that I have. I mean, there is one additional thing. Like, I think that it's really worth calling out that if we take a look again, one moment here. Yeah, I just really want to call out these predefined roles: admin, edit. So the admin role covers basically everything within a namespace. And what you can do is, I'll give an example of this in a moment, but if you grant the admin role, then what you're doing is you're giving a user the ability to do everything within one namespace. And that includes managing RBAC permissions within that namespace. The edit role is everything within a namespace except for managing permissions within the namespace. But they would still be able to do deploys and delete pods and scale things, all of these things. And the view, as you may guess, is quite more restricted. You can list things. And so these predefined roles can probably get you quite a ways. If you're separating up a development cluster, for example, you're just going to probably grant the admin role either to most of the people on the development team, or all or most of the people on the development team. You might have more structured where only a few people have admin and the others have edit, but that might be too much level of granularity. But what we'll do is we will just, a reasonable scenario that I expect is going to be something like this. So well, not like that. That's the role. I want. So here's what I'm going to do. I'm going to create account 1 admin, and we're going to say that the cluster role admin user account 1. So I'm using a variable to capture what account 1 is, because account 1 is the, I'm sorry I didn't talk about that earlier, but account 1 is, that variable just has a really long thing that looks like an email address, and it's a GCP identifier for a service account. So no hidden magic, it's just the identifier. And so what I'm going to do here is, this is going to give the user 1 admin privileges in their own namespace. And if we do something similar, user 2 in their namespace, and the other thing that will probably be interesting is so this is going to grant user 2 view access to namespace 1. Got that right? Okay, so I think that a scenario like this, if you happen to be sharing a cluster across teams and you do want to divide responsibilities, this may be the most interesting set of commands for you. If you just give away the admin privileges to the people on the team in namespace 1, you may want to give them view privileges into what everybody else has, so that they can actually go and look and see, are their pods running? What ports are they listening on? Why am I not connecting the way I expect to? Being able to answer those questions for yourselves really helps velocity, but they don't necessarily need admin permissions in everybody's namespace if you're dividing responsibility. And so, you know, although I've demonstrated how you can really break it down at a fine level of granularity, certainly from the perspective of ACute Control, these commands here are probably some of your most interesting.
Definitely, and thank you so much for detailing more of that delineation of duties across users and accounts. That's really exciting just to see, as Anthony was mentioning, how you can fine-tune this to work across your organizations and across your teams, so that there's this pipeline of collaboration going on, but at the same time, only the teams that need to have access, either from rights or from admin or just from a viewing perspective, suddenly have that control. And you can really get down into the granularity and fine tune it to each team's unique needs, which I think for any company, whether it's a small business, SMB, or a large enterprise company, you still need that granularity of control. And so being able to do that easily within Kubernetes is fascinating, and I know so helpful. So we definitely appreciate you taking the time to go through this today with us.
My pleasure. Thank you for having me.
Awesome. And so we'll open it up. If there aren't any, doesn't look like there's any outstanding questions. But if you do have a question, please throw it in the chat.
We'll be sure to get it answered.
Absolutely.
Yeah.
So Jacob, any last things you want to mention, or otherwise I think this has been a very helpful, at least from myself, it's been a very helpful session. And so I think that, the people attending would echo the same sentiment, but.
No, I think that, yeah, the level of maturity that RBAC has really come to in 1.6 is really neat. Being able to do all of this from the command line like this and being able to give it away, this is pretty cool. This is the tool that you like to be able to use.
And you make it look so easy, which I think is the most exciting part. It's no longer, having to code long lists just to make sure that everyone has the permissions that they necessarily need. So it's exciting to see how easy it is, or at least you make it look easy.
Well, I try.
Great.
So yeah, so I put and part of easy is frankly having a trail to follow. So the documentation is useful, and everything that I did here is in the walkthrough. So if people want to grab it and experiment, it's up in GitHub. Go to town.
Awesome. And I'm just going to quickly share the walkthrough. So this is the walkthrough that on GitHub that Jacob went through today, and so you can, we encourage you to go test it out yourself. And again, we're excited with RBAC and all the other things that are in the pipeline for Kubernetes. So
coming soon to a Kubernetes cluster near you.
Exactly.
Any further questions, go to cloud.google.com or feel free to shoot them our way.
Awesome. And I'm also throwing in the URL to the walkthrough in the chat.
I'm sorry, there is one caveat that I would like to throw in there.
Please do.
Yes. I really should have led with this. It was in my notes. So due to some scheduling challenges, some of the commands around being able to work with RBAC on GKE won't be available until early next week. And so this demonstration has been on a special cluster that's available to me as a developer, but things are still being deployed. So if people go and find the walkthrough, the warnings are in there, but those changes are in the pipeline and they are coming out.
Perfect. And will they be in the notes on the GitHub as well?
Yes, the notes about the warnings that things are unavailable and the versions to look for when they will be there are in GitHub.
All right, perfect. Well, thank you so much for your time this afternoon, and thank everyone who joined us this afternoon as well. We definitely appreciate it.
Great, and we'll have a good rest of your evening, day, or wherever you're at, and we will see you in episode 10.
We look forward to seeing your application in the cloud. Thanks for joining us.
Thanks, Jacob.
Thank you very much. Take care.